Let's build a multiplayer mobile shooter game. Hello, in this video we'll learn how to create easily this multiplayer game from scratch with the help of Playroom, who is kindly sponsoring this video. Playroom is an incredible toolkit that brings multiplayer functionality to your projects without having to develop or host a backend. It's ideal for indie game developers or small studios seeking a scalable solution to provide players with a seamless gaming experience. Together, we'll be using React Refiber, but it's also compatible with the most popular game engines such as Unity, Phaser, and Play Canvas. Best of all, Playroom is free for indie games, students, and game studios just starting their journey. So let's explore its features while we embark on our game building adventure. Let's start by getting the starter pack and cloning the repository. Code, copy here the URL, then clone it anywhere, run yarn to install the dependencies, and yarn dev to start the development server. Then you can click on the URL here, and you should see this cube that you can rotate around. For this tutorial, we'll be using the royalty-free pack from Quaternius. Don't hesitate to support him on Patreon. I downloaded the different assets and prepared a map from it. I just added a floor, a basic floor, and some walls to not go beyond that zone. The zone is 40 by 40 meters. I just added a lot of items from the pack, and I also created spawn. The black box is here. This is nothing visual, it's empty boxes. You can't visualize them when we will load them into our 3D, but based on their position and their name, we will be able to spawn our player randomly on the map. On the final code, I will provide you the Blender file and the GLB file, so feel free to use it and to modify it. Download the assets, go to Public, Folder, Models, and drag and drop them here. You should have the map, it's the one that we've just seen, and character solder, which is the character from the pack. Let's start by displaying our map. So we go into Source, Components, and we create a new one that we name map.jsx. We'll create a component named map. We use GLTF to load the model located in models, and we also do the same, but with preload, to be sure it's loaded at the very beginning of our app. Then what we do is we return a primitive with the object is equal to map.scene. Now inside our experience, instead of showing that box here, we can render our map. Now let's adjust the global settings. Go to app.jsx, change the position of the camera. By default, we will put it on the top. While we are here, we can change the background color of our experience and add some default lighting settings. In experience, we'll add environment with the preset sunset. If we reload, we can see our 3D map is ready and loaded. That looks a bit flat, so let's add some lighting and shadows. To enable shadows, we have to go to our map and in a use effect, go through all our objects in our scene on each mesh and enable shadow and receive shadow. Then we need to add a light that will cast the shadow on the object. So go to experience and we will add a directional light. We define its position, its intensity. We say cast shadow, so it will apply it on the mesh that receives shadows. And we define other options to make sure that all our map is impacted by the shadows. I won't cover it, but you can look at the three.js documentation about shadow map camera. Now, if we reload, we have those nice shadows available on our objects. To make it even nicer, we can go into app.jsx and on top, add a soft shadows component. What it does is just on the existing shadows, it smoothens them to make them less harsh. Our map is ready. Let's add Playroom SDK to load our players. You can find the link to Playroom in the description. Let's follow their instruction to install it into our project. In the terminal, we can stop the development server, run yarn, add and Playroom kit. When it's done, we can restart our development server. Now it's pretty easy. What we need to do is to follow the steps. So the first one is insert coin. We'll add it into our experience. We will create a use effect. So when it's loaded, we will call a start function. So not start transition, but start. And our start function, why do we separate it? It's because it needs to be async. Inside, we can paste our insert coin. Now, automatically, when we reload our page, we have a room that is created and ready to host a game. We can choose a random avatar by clicking here. We can rename ourselves and choose a different color. If we look at the URL, it contains a room code. We can also get it by doing invite, and we have a QR to scan to share to our friends or the share link button. Then if I open a second tab, we have automatically all the players in the lobby that joined the room. Let's follow the next step. We need to handle when other players are joining, to add them into our state and to create our logic across the different players. We will need a state to store our players. So we use state an array of empty players. Now we can define our logic. On player join, we will have the state of the player that is joining us. It's automatically provided by Playroom. Then we need to create a joystick for each player. It is synced through the network, so each client will have access to the joystick of all the other players, but it will only create a UI for the current player. There are two types of joystick. One is D-pad, so you know if it's left, right, top or bottom. But us, we will be using angular, so you can easily rotate at 360 degrees. Then we'll add a button, fire, so we can shoot in the game. And we create a new player containing our network state and our joystick inside our array of players. Then on the network state, we define the health to 100 by default, the number of death, the number of kills, so 0 by default when you join the game. And we add the new player to the existing array of players. Then we need to handle when a user quits the session. We remove it from our array of player in our state. Now we have our array of player, we need to create a component to render the actual character. Let's create the component. Inside components, character soldier.jsx. So what I did is I prepared the component based on the GLTF file available here. As usual, I used GLTF JSX to generate the component for me, but I added some code that I will explain to you. First, to be able to use that component, we need to add another library, which is 3stdlib. Let's copy it here, yarn add, and add that library, yarn dev. So let's have a look at what our code is doing. We have the list of weapons our 3D model contains. Then I defined 3 props that we can use on our avatar. So we have its color. It's coming from Playroom color that we decided in the beginning, the current animation we are playing, and the weapon our character is holding. We won't change it. It will be always AK, but you can change it later. Then it's the usual code to display a 3D model. We have skeletonutils.clone and useGraph to be able to reuse the same mesh, because we'll have multiple players and we need to clone the mesh to be able to reuse it and not to have them disappear. Then we load the different animations. I define that when it's the death animation, we are setting it to loop once. So it's not looping through the death animation, but once it's dead, it stays in the dead position. And finally, we are just defining the player color material, which is based on the color we have in the props from Playroom, and we apply it to a material that is named character main. This is the shirt and the headset. Okay, so this character soldier component is just to render our character, but it's not where we will put the logic of our character. For this, we will create another component named character controller.jsx. Let's create the component character controller, and this we will code it together. We will need the following props. So the state, the joystick, user player, it's a boolean to know if the current controller is our client or if it's another player that is remote. And also the rest of the props. For now, we will return a group. We might need a reference later, so let's create one. Const group is equal to useRef. And inside, we will have a nested group for our character. We'll name character, a second reference. And inside that group, we will add our character soldier component. We need to define the color. So we have it from state.state.profile.color. And we need to also define the animation we are currently playing. So we need a state to know what animation we are currently on. So animation set animation is equal to useState. And by default, it will be idle. Let's render our character inside our experience. So now inside, we can say if we have players, we will map through each of them. We will get the state, the joystick, and the index of the current player we are on. And based on that, we will render a character controller. The key will be state.id. It's a unique identifier we get from Playroom. We get the state and the joystick. User player is not the correct code. We can check if we are the current user by doing state.id. And to check if it's equal to my player, so it's a method from Playroom kit, .id. So if it's the same, it means it's me, the current player playing the game. Let's also adjust the default position. We can say position x is equal to index multiplied by 2. It's temporary, later we'll do it another way. Go to character controller. The rest of the props, we will apply them to the controller. Now if we load two tabs, we have our two characters in idle stand next to each other. Now we have our player ready. We need to react to joystick events to move the character. To be able to move our character, to handle collisions, and that bullets hit the players, we will need a physics engine. We will be using React 3 Rapier. It's a wrapper around the Rapier library. I won't explain it in depth as I already have a video dedicated to this topic. You can find the link in the description. Let's install it into our project. We need to stop the development server, yarn add at react3/rapier. And once it's done, yarn dev. Now we need to go into app, wrap everything into suspense, and our experience, we will wrap it into physics. By doing it, it will create a physics-based world. But alone, it won't do anything. It is because to have meshes affected by the physics, we need to wrap them into rigid bodies. Let's start with the map, because we want it to handle collision when we hit the objects or when we hit the wall. And also our character not to go through the floor. Instead of just returning a primitive, we will return a rigid body from Rapier. We can define its colliders and set it to tree mesh. So it's a complex shape. It will be based on our meshes inside. If we reload, you can see that the map is falling. It is because it is affected by gravity, so it's always falling. To avoid the map to be affected by gravity, we can change its type to fixed. Now our map isn't moving anymore. To understand what it is doing to define it to tree mesh, we can go to App, Physics, and add the debug prop. That way you can visualize all the rigid bodies applied. So it wrapped all our meshes with some colliders, so we will be able to use it to move our character and to not go through all the different items. Now let's make our character move. Go into character controller, and we don't want to move the mesh, we want to move its rigid body. So first we need to add one. Inside here our group, we will add a rigid body and wrap all our group that we will fill later. That's why we have a group, I will explain to it later. We will define its colliders to false, to not have default one collider, and we will need to add our collider manually, because for our character, the one we want to use is a capsule collider. Here is what it looks like. It's wrapping our character, and it's what we will use. It's not a complicated one, so it won't be too expensive for the calculation, but it represents correctly a human. To be able to move our character, we need a reference on the rigid body. We'll name it rigid body. We need the reference on it, and our logic will put it in a use frame. First, we need to get the angle that is applied on the joystick. So we have the is joystick pressed to know if the user is currently pushing the joystick. If we have an angle, Then we will set our animation to run, and we will rotate our group in the direction of the angle. So here in this group, we will rotate it to follow the joystick angle. Then we will move the character in the right direction. So we will create an impulse, it's a force, we will apply to the rigid body. We are doing some basic calculation based on the angle and a movement speed and the delta. We will define them later. And we apply that impulse into our rigid body. So the movement will be physics-based and it will react to collisions and gravity. Then if it's not the case, we are not moving the joystick, we will just set the animation to idle. We are missing some variables. Here we have the state, we can ignore it. And we need the delta time to have a smooth movement based on the frames. And we need to define our constant movement speed. So find the one that you prefer, but I chose one. So movement speed is equal to 200. Now let's try to move our character. If we move the stick, we can see it's going way too fast and it's rotating and falling. To add some friction to our rigid body and to not move that fast, we need to add linear damping and find the appropriate value. I decided to use 12. Now let's try it again. We can move the camera and move. It's better, but you can see our character is falling because the capsule reacts to the physics and it falls. But we don't want our character to be impacted and to rotate. So we need to lock the rotation with the lock rotations prop. Let's try it again. We can move our character. It's not falling anymore. And if we go into walls, because it is physics-based movement, it is automatically blocked by the other rigid bodies. While this works with one player, if we move our different players, you can see that the positions are not exactly the same. So we could have gameplay issues. You see here I'm blocked here, but on that screen, the position is not exactly the same. So it's going to another position. To avoid this, we need to put another system in place. When we use Playroom, automatically one of the user will be defined as the host. So we'll be using that feature to say only the host will do the physics-based calculation. And the other clients, which are not currently the host, they will just display what is happening on the screen. Automatically, if the host disconnects, the other client, one of the other client will become automatically the host. So we can continue to play and have the logic. Let's implement it. Inside our rigid body, we will change the type if we are the host or not. So if we are the host, we can know it using the isHost function. Then we will use dynamic. This is the default one we were using so far. If it's not the case, we will use the kinematic position. So we need to define ourselves the position of the rigid body. It won't be impacted by the physics. So now let's go to our useFrame loop. If we are the host, we will set to our current state the position. So the state is the network state we have from Playroom. We will set our position. It will be the position from our current rigid body. If we are not the host, we will get the position from the state. And if we find one, we apply it to the rigid body. Now, if we move our character, it's perfectly synced between the different clients. You can see if we move, we are at the exact position, we can push the other. It's accurate, and we are sure all our players have the same experience. Now, because it is boring to move the camera manually, let's make a camera that follows automatically our character. Go to Experience, we will get rid of the orbit controls, and instead, in Character Controller, in our group, we will say, are we the user player? So only for us. And if it's the case, we'll be using camera controls component. Be sure it's the one from Dry because it's also in 3stdlib. We'll need a reference on it. We'll name it controls. Let's define our reference with the other ones. So controls is equal to useRef. And in the useFrame, we will make it follow our character. First, we need to check if we have a reference on controls, because if it's the other character controller, we won't have one. If it's the case, we define some distance on the Y and Z axis. I define some conditions to make it closer to the character if we are on mobile, but it's a bit dirty the way I did it. Then we get the position of the rigid body, and we are using vec3, it's a method from Rapier, to convert it from Rapier physics to three.js physics. Then on controls, we are using the setLookAt method to define where our camera is, so a bit further away from the character. and to look at the character position. Now we can try to move our character. On the left, the camera is following, but it's independent for each client. By the way, we can disable the debug so it's faster and it's less ugly. Let's try it. We launch and we have correctly all our characters. Nice. Because it's a shooter game, we need to handle the fire button to shoot actual bullets. Let's go back to our character controller. Go at the end of the useFrame function. To know if the player is pressing the button, we have joystick.isPressed and the name we defined earlier, so fire. We define automatically the animation to idle shoot, and only if it is the host, we will do the action that are physics-based. We will need to check the date between the last fire so we can shoot like 100 bullets at the same time. Then we define the last shoot date. We will need to create a reference for that. Then we create a new bullet. We add an ID to it, so we'll be able to map them and to avoid re-render issues. The position will be equal to our position of our character. The angle is the one we are currently at. And we also save whose player is firing, so we'll be able to count the score later and know who killed who. Once we have our new bullet, we'll call a onFire method to add that bullet to the list of the bullets. Nice, so to be able to do it, we need to define a fire rate. Go on top, const fire rate. I chose 380, but it's up to your creativity. Then on the character controller, we will need a new event. It will be onFire. And we also need a reference to know when was the last time we fired. So last shoot is equal to useRef of 0. Now let's go to our experience and handle that onFire event. We'll create a method called onFire. Inside our experience, we will need to have a list of bullets. So it's a state, we set bullets. It will be also an empty array by default. And what onFire will do, it will take the bullet that we pass it as a parameter. We just set bullets to the previous bullets array with the new one. So every time the player hit the fire button, it will call onFire, and it will add a bullet to our bullets array. Now our bullets array should be filled, but we need to render them. So like we did for the players, we will render all our bullets. So we'll create a bullet component, but we don't have it yet. We will be using the ID we defined as the key, so it's bullet.id, and then the rest of the props. And finally, to know when we will make our bullet disappear, we will create an onHit callback. So we'll call onHit function. But we need to pass some parameters. So it will be onHit, and we will call onHit of bullet.id. Now let's go on top where we have our onFire. We will have our onHit with the ID of the bullet. So I prefer to name it bullet ID. And we will set the bullets to the previous array of bullets filtered with the one that has been hit. So it will make it disappear from our array of bullets. Let's create our bullet component. Go to components, new file, bullet.jsx. Export const bullet is equal to, we will return a group. We need to define its position. So it's based on position.x, position.y, and position.z. And the rotation y will be the angle from where the player is shooting. In our bullet, we will need a rigid body. And inside, we will just render a mesh with a box geometry and a special material. For the material, we will be using a mesh basic material with a hot pink color, tone map to false, and we'll multiply the scalar to make some bloom effect just after. We will need a reference on our rigid body. We'll name it rigid body. Const rigid body is equal to useRef. And in the use effect, we will apply the movement of our bullet. So use effect, when we instantiate the bullet, automatically it will go in the direction it is supposed to. To do this, we define a velocity. It's the same calculation we did for the movement based on the angle and the bullet speed. And we define the linear velocity because it's a fixed speed for the bullet on our rigid body. Now we need to define our bullet speed. const bullet speed is equal to, and I chose 20. Let's try it to see what we have. Let's go to our experience and import the bullet because we didn't create before, so we couldn't. Let's try to see what we have so far. If we fire, we can see our bullet is moving in the correct direction. But as you can see, the position of the gun is slightly off track compared to what our bullet is coming from. To avoid it, go to character controller. On top, we create something called weapon offset, and we will use it to move the default position of our bullet. So let's go back to it, and we will wrap our rigid body inside a group that contains the weapon offset. So automatically, it will never be at the wrong starting position. Let's try it. We can move, fire, and you can see it's almost going from the perfect position. Of course, you can adjust it, but it must be difficult for the player to know where it's aiming because there is no indicator. We can create a simple crosshair for it. Let's go to character controller, and below it, I prepared a very simple crosshair. So it just meshes one next to the other one to draw a line of very small boxes. Now inside our character group, this is the one that rotates. Next to the character, we will display our crosshair. To make it appear at the right position, we need to set the position to the weapon offset. And we also need to have it only for us and not to see it for each character. So we need to add a condition, user player. If it's the case, we display the crosshair. Now we have that small crosshair visible, so we know where we are shooting to. But you can see we have an issue. When we shoot, our bullet go off track. This is because currently our bullet is impacted by the fact that this is a rigid body. It is impacted by gravity, and we don't want it. We just want to follow its natural path. To avoid it, we can define it to gravity scale and set to 0. Then to prevent that when we hit another object, like a player, it impacts its movement, we need to set it to sensor. So when it's a sensor, it will just notify when it enters in a collision with something, but it won't impact the rigid body that it hits. Now let's add the logic when it hits something. So on intersection enter, it's because it's a sensor, so this is that callback function. If it's the case and we are the host, because only the host will handle that logic of the rigid body and the physics world, and if the other item isn't a bullet, because we don't want to have any relation between bullets hitting other bullets, then we will disable the rigid body. This is to prevent that it hits a player 2 times or it hits 2 players at once. Once a bullet do something, it's disabled. Then we will call the onHit callback, and we will pass the position of where it was hit. We also need to add some user data to our rigid body, so on the character controller, we'll be able to code our logic to be hit. So we'll say it's a type bullet, we pass it the player ID, and the damage of that bullet. It's hard-coded, but if you decide to have multiple weapons, you can be based on that. Now let's try to shoot, and the bullet disappears, and it follows precisely the trajectory of our crosshair. Currently, our bullet is white. Let's add the post-processing effect. To do it, we need to add React 3 post-processing, then yarn dev, then add our effect composer and our bloom effect. The effect composer comes from React 3 post-processing, be careful on that, and same for bloom. Now you can see that when we shoot, there is a nice bloom effect. But we have an issue since we added post-processing. There are some artifacts on our object. To prevent it, we can change the stings on the camera and set the near property to 2. By doing that, we won't have the precision issue and have the correct rendering. I also prepared some audio files. You can go to public, add audios, and drag and drop the files here. We have dead when our character has 0 health point, hurt, and a rifle. In the use effect of our bullet, when it is instantiated, we can play the sound of audio rifle. If we try to have multiple characters, you can see it's moving correctly. Each one has its crosshair, and if we fire, only one is showing the bullets. This is because we have a local state. To display it for the other clients, which are not the host, because if we fire on the other client, which is not the host, it will fire, but only on the host client, which is on the left. So we will have a network state where we will be able to display those bullets. Thanks to Playroom, it's very easy to do. We have our bullets here, which are our local state, but we will create a network bullets and set network bullets. And Playroom provide a use multiplayer state, which is the first parameter is the name. So it's named bullets. And the second parameter is the default value, so an empty array. We will have a use effect when our local bullet change, so based on our bullets. And what we will do is set network bullets with our array of local bullets. Then we just need to render the correct array. So if we are the host, we will render the bullet, which is the local state. But if we are another client, we need to display the network bullets. To do this, we can go on our map function. And here we will check if we are the host, then we render the bullets. If it's not the case, we render the network ones. Now, if we fire on both clients, we can see the bullets are moving. Now let's handle when we shoot another player. Let's go to our character controller. And as we did on the bullet, we will add an event to know if we are hit. So on intersection enter, we can get the other. And we will put our logic here. So if we are the host and the other rigid body is a bullet, and if we are alive, so our health is above 0, then we will calculate our new health based on our current one and the damage coming from the user data of the bullet. If it's below 0 or equal to 0, it means we are dead. So we will increase the counter of death on this player. We will set its state to dead and the health to 0, so it's not below 0. And we will disable the rigid body, so it won't be impacted by the other bullets that are firing toward the dead corpse. Then with a set timeout of 2 seconds, we will call a method spawn randomly to appear at another place, and we will re-enable our rigid body to be able to play. We also set our health to 100 to restart from a fresh start, and we are not dead anymore. And we also call onKilled to increase the stat of the player that killed that player. And if we are still alive, we just set our new health. This contains something that we didn't implement yet. So we have onKilled. We need to add it to the props of our character controller. And we also have a function named spawn randomly. So let's create it. First, we are getting the scene from user 3. So it's the global scene. Then we create our spawn randomly method. We will get all the spawns. I chose a dirty way to do it, so we loop from 0 to 1000. And based on the naming I chose on Blender, it works because we only have 10. So we search for an object named spawn underscore and the number of the spawn. So for 0, 1, 2, 3, it works. Then if we find a spawn, we push it to our array of spawns. If it doesn't work, we stop to loop through 1000 items, which means we didn't find another spawn. Then we choose randomly a spawn from the array of spawns, and we set the translation to our rigid body with the spawn position. Now that we have that method that we call when we die, we can also call it at the very beginning. So use effect when our character appears, if we are the host only, because it's always the host that is in control of what is really happening in the game, and we call spawn randomly. And because we do this inside experience, we can remove the default position we set earlier. Let's try it, and we appear at a random position on the map. To try our system to see the health on our character controller, I prepared another component named player info. So it's using a billboard and some text and also some plain just to display the health of the user and its name. As we did for the crosshair, we can add it on our character here, but it doesn't have to be conditional because we want everyone to see the health and the name of the other players. Okay, let's try to shoot the other player. We can see the health is decreasing, and when it's die, we have an issue because it doesn't get back to 0. And we should show an animation that the player is dead. The issue we get should be because we don't have the onKilled yet for the score, but we will do it later. For now, let's go to our use frame. And on top of it, if we are dead, we just set our animation to death and we stop moving our character or doing anything else. Now we can go to our experience and define the onKilled method. So onKilled is equal to onKilled. Let's define it here anywhere. So onKilled, we have the victim and the killer, so who has a score increased. We'll find the player from our array of players based on the ID, and we just increase its kills. Let's create a simple leaderboard to see the kills and deaths of the different players. Let's go to components, create a new file, leaderboard.jsx. Export const leaderboard. To get the list of the players, we just do const players, and we use the hook named use players list from Playroom kit, and we can set it to true to have always the up-to-date values. Then I prepared a simple UI to render for each player, a box containing the avatar of the player, its name, and its number of kills and death. I also added a button to toggle full screen so it's easier on mobile to play. Let's go to our app and add our leaderboard. So it will be out of the canvas, which is meant for 3D items. We will add our leaderboard, and we will also add the loader component from React 3 Dry. All our resources will be loaded before displaying anything. And this looks very bad because we need to add Tailwind. Let's follow the instructions to add it. So copy it, yarn add the different libraries. Then we need to run Tailwind CSS in it, paste it. It generated a config file. We need to define this. So far we can run yarn dev and close it. Go to tailwind config.js, change the content it's applied to. So it will be applied to index and all our JSX file. And inside our CSS file, we need to paste it. So index.css on the top, we add this. Let's see if it works, launch, and we have it correctly. Let's try to find our other player and kill it. I think it's on the top left, yes. It's not very practical to play the joystick with the mouse, but there is an option to play with keyboard. And for recording the video, I can show you on the phone right now. So let's click on fire, try to kill it. The animation is played correctly. You can see that the stats are accurate. Boom has 1 kill and Cornflakes has 1 dead. Very nice name, by the way. We are almost good. We will add a final effect. When we hit a wall, when our bullet disappears, we will add an impact effect. I prepared an interesting component named bulletHit.jsx. I prepared everything. What it does is it generates a number of small boxes with a random target position, and it will act as an explosion. And I'm using instance mesh to avoid it to lag too much. So like we did with the bullet inside our experience, we'll create a new state. So also for the network bullets, we'll name it hits. So hits, set hits, network hits, and set network hits. This is very bonus. You don't have to do it if you don't want. What we need to do is on hit, we also get the position from where the hit was done, and we will add a new hit to our array of hits here. We add a new hit with the ID of the bullet, so it has a new unique ID, and the position to know where we instantiate our effect. Then we create another function on hit ended just to remove the hit. And exactly like we did with the bullets, we add a use effect on the hits to synchronize them through the network. So set network hits with the new value of hits. So all clients can see the same thing. Now let's go on the bottom of our experience. It's not a lot of code here, so it's almost the same logic. If we are the host, we will show the hits. If we are not, we'll show the one from the network. Then for each hit, we will render a bullet hit. The ID will be hit.id. We give it the rest of the props. And it's not on hit, but on hit ended. And we will call on hit ended with hit.id. But we changed on hit to take 2 parameters, the ID of the bullet and the position of the hit. I don't know if we already have it in the bullet. On hit, we are already passing the position. So what we can do is on experience, get the position here and pass it as the second parameter. Oh, and I made a mistake. It's on ended and not on hit ended. Let's try it again. We launch it on the host. We can try on any client. We can see the explosion effect. If we try to find the other character, we can aim it, fire, and we see the correct explosion. If you want to try it on mobile, you don't have to do just yarn dev, but do yarn dev -- host. What it will do is generate that network URL that you can access to and use that one. And on a device connected on the same network, you can either copy and send the URL or click on the invite button, scan the QR and play together. Thank you for watching. I hope you enjoyed this video. A huge thanks to Playroom for sponsoring this video. I really enjoyed using their SDK to build this amazing project, and I highly recommend you to give it a try. Link in the description below. To go beyond this tutorial, you can, for example, create other maps, add rules such as duration or set a number of lives to end, and display the winner of the game. You can also change weapons and create other types of bullets and impact effects. Another way to motivate you is to join game jams such as the ReactJam or AxieJam. If you enjoyed the video, please hit the like button and subscribe to not miss the upcoming videos. If you want to continue learning, I also created React 3 Fiber, the ultimate guide to 3D web development, a project-based course to learn everything you need to know to feel confident to build your own 3D experiences. Or you can continue watching my free video tutorials available here.